Hello everyone, today I'm going to show you how to use tracker software and also my life to solve the problem I mentioned in the previous video. The software can be downloaded through this website and it can be used on Windows, OS X and also Linux system. I've already downloaded and let me open it for you. Just wait for a second. And this is the tracker software. And first we need to import the video that we want to analyze. Click File, Import, Video. And here I will use video 1 for an example. Just click video 1 and open it. Just wait for a moment. As you can see, the video has shown here. And first, we need to change the frame rate to 240 since we use the slow motion video. Change it here. Click OK. And then we need to teach the software what the distance scale is. Look at the yellow line here. The yellow line in all the videos is 1 meter, which is 3.2 feet. So let me click this one to set up new calibration stick. Press Shift and click to select the start point. It's right here. And keep pressing Shift. Click to select the endpoint. Let me change it to 3.2 feet. Click Yes. Please pay attention that all the units you need, whether in the tracker software or in the MATLAB code, it should be feet or inch, but not meter or centimeter. And then we need to set up the initial point. I like to click here to show the coordinated axis. Move it to the center of the ball. So here's the thing. Please pay attention that we need to start tracking after the ball leaves the hand. So I like to zoom in to find the proper start point. So I think just here, the ball just left the hand, it should be a right point. And let me move the 0 point to the center of the ball. And then we need to create an auto tracker. Click Create here, Point Mass, and we saw it's a Mass A here. Click Mass A, Auto Tracker. As you can see here, to create a new keyframe, Shift and Control and click the video feature of interest. Just press Shift and Control and click the center of the ball. Oops, it's missed a little. I think I can go back to the original one. Now I like to zoom in a little. And way back to the original size of the video and click Search. As you can see, the software started to track the trace of the ball movement and give you a series of data of the time and the position of the ball. Show here. When the ball touches the bottom of the video, click stop and accept it. So here, as you can see, we've already collected a series of data of time and the position of the ball. The final point of the ball here is 5.1 along y direction and minus 1.3 along y direction. That is because we set up the start point here but not along the final point here. But we will need this at the initial head to calculate the horizontal traveling distance of the ball. So I will use here 1.3 as the initial head of the ball. And what else do we need? Yes, we need the initial velocity of the ball along y direction and also the initial velocity along x direction to calculate the distance. So let me open the MATLAB code for you. For the MATLAB code, we got a master code and an experiment data file. As you can see in the code, we can change the drag coefficient here, and we can change the initial vertical position, which is the initial head of the ball. We can also change the initial velocity x and the initial velocity y. So we back to the tracker software to find what we want. We can change the y-axis to velocity x component and find the start point. Things right here, which is 7.976. 7.976. And we change the y-axis to Vy. And also find the start point. The initial velocity along y direction should be 9.51. 9.51. Sorry. And also the initial head should be 1.3, no 1. 1.301. And also we need to put the experiment data here. So let's back to the track software. I use Control and A to select all the data we need, and right click, copy selected cells and full precision. Back to the experiment data file, select all the data here and delete it, paste to what we want here. And also we need to delete the notation here and check. So it should be outside. We can run the code and see what's the result. So as you can see, here is the trajectory of the ball. The blue line is the theoretical result and the red line is the experiment result. So here you can see the error between theoretical and experiment result, and it is 0.0145. So we can change the drag coefficient here to see what will happen. I like to change it to 0.6 and run the data. It become larger, so we need to change it more large. 0.8 shows. It becomes closer. The error is 0.0091, and we can repeat the step to make the value you got from the experiment is closer to the value that based on the theoretical calculation. So that's it. Thank you.